Okay. So there was a question about this double, something like this double list comprehension. And the example was given a list of lists, which can kind of be visualized as a matrix, and it wrote out this complicated looking double list comprehension, nested list comprehension, I guess, that effectively transposes this. So you have a matrix with 1, 2, 3, next row 1, 2, 3, and it transposes it, okay, and it becomes columns instead. So let's figure out why this works. But before we do that, let's just make sure that we understand how list comprehension works. I do suggest you watch the videos that are provided about list comprehension, and especially converting them into for loops, because that's kind of what's going on here. But if it helps, you can think of it as a for loop. So let's forget about this for a second, and let's consider just a simple list comprehension, okay? We've got, say, L is 1, 2, 3, and our list comprehension says we want LR, for the reverse of L, is going to be L element number I for I in L. Or maybe what I should do is, no, forget that. That's not what I want to do. That doesn't make sense. That would be, actually that was not going to work. Let's do range, let's do it from 2 down to -1 in increments of -1. So it's going to be 2, 1, 0, and then it's going to stop. It's not going to include this -1. Okay? So how does this work? Well, we need to make a for loop in order to understand it, and that's one way to understand it. Okay? For I in range, so this is what's equivalent to -1, -1. So let's make it simpler on ourselves. Let's write out what this actually is. 2, 1, 0. Okay? And first of all, we probably need to create an empty list LR. That's what we need to do. That's effectively what it does. Create an empty list, because that's what we're going to save to it. And we know that because we're evaluating a list comprehension, it knows to create an empty list, basically. And then it says for I in range, whatever you have here is your loop. And what it does is it takes LR, it appends whatever you have here. That's all it does, is it starts out with an empty list, and it appends whatever you have here before the for to the end. Okay? And so what effectively happens is you go through, you start out with an empty list, right? Okay? And you go through and you say, all right, for I in this, so it starts out with I is 2. Well, element number 2 is 3. We're going to append that 3 to LR. This is LR here. Okay? LR, we start off with 3, and then I in range to -1. So I in this one, we get to the argument, this element. So I takes on the value of 1. We append L element 1. L element 1 is 2. We're going to append that to LR. So 2, and then finally, comma 1, the last version. So this effectively reverses it. Okay, but we need to just remember, the point being is when you see a list comprehension, you create an empty list, you take this part of it, and that is your for loop, and then you say, empty list, whatever started out as empty, we're going to append onto it every time whatever we put here. Okay, so that's how list comprehension should be evaluated. All right. So let's construct this transpose accordingly so we can visualize what's going on here. I'm not going to write out the equivalent for loop for this one. You can do that on your own. It might be a little bit tricky to think of it that way. But so let's just go through it, though. I think once you see these, instead of writing out an equivalent for loop every time, it's good to just see how it works. So we start out actually on the right side. Well, actually, no, we start out by creating our empty MT. Okay? Just going to have to be nice and big maybe, I'm not really sure. All right, and so we say for I in range 3. Okay, so start off with I is 0. Ugh. All right, then, all right, move on. So the inner for loop, essentially. Row I for row in M. Initially, row takes on the value this first row. 1, 2, 3. So let's actually, we could point to it, and that would probably be more appropriate as we create a pointer to this row. So row is that, and we're going to take row I, row element 0, 1. Okay, actually, well, I should probably have specified, because we saw this is an inner list comprehension, we had to create an empty list. Okay, and we're going to append onto it element 0 of this row, so this one here. Element 0 of this row is 1, so we append that. Okay? We continue evaluating this inner list comprehension. We're going to now append row I is going to take on the value of 1. No, actually that doesn't happen yet. Nope, doesn't happen. I stays 0, this stays the same. We're going to go to the next row in M. The next row in M is 4, 5, 6. Yeah, that's what happens next. That's the inner for loop, right? 4, 5, and 6. We say element 0 of row, which is now this one here. 4. Okay. We have gotten to the end, but we got to the last row of M. There's no more rows left in M. There's no more lists left in M. So we're done with this inner list comprehension for this outer list comprehension. So now we need to let this outer loop, this outer list comprehension, I needs to take on its next value. So I now takes on a value of 1. Oh, by the way, we appended, once we finish this, we append that to this empty MT. All right, so now we say, all right, we're gonna also have an empty list that's appended on this. It's initially empty. I is 1. Row is going to start off being 1, 2, 3. We're going to take element 1 from this, which is the 2, and we're going to append it to this empty inner list. And then we switch over. Row is in the inner loop. We go to the next row of M. It takes on 4, 5, 6. And so we're going to get element 1 out of this list, which is 5. Okay? We finished the inner list comprehension. We get back to the outer loop. I takes on the next value of 2. And then row takes on, again, goes back to here because we're now starting off with this inner list comprehension. The inner list comprehension starts out with an empty array or an empty list. And then we go through it and we say I is always going to be 2. We're going in each row in M. So I is 2. We're going to get element 3. We're going to append it to the empty list. And now we're going to append element 3 of this row, which is, or excuse me, element 2 of that row, which is 6. Ooh, goodness. And that effectively transposes our list of lists. So that's how it works. Maybe I should go ahead and write out the equivalent for loop so we can see for double list comprehension what that for loop is, and maybe it would have helped us to evaluate it. All right, so we start off with whatever is here. We're going to start, oh, well, no, first of all, we start out with MT is an empty list, right? So applying the same logic as for a single list comprehension, we say for I in range 3, we are going to have an empty list, and I don't know what to call it. There's no variable name for it, so temp gets empty to begin with. We're going to append whatever happens from here, actually. Oh, well, maybe the best way to put it is this is not true Python code, but here's the best way to put it, right? We want to make this look just like it did for a single list comprehension, right? So let's make it look more similar. We're going to append to MT. We said we're going to append whatever happens here. Whatever appears before the for loop is what's getting appended. But this is a list comprehension in itself. So we've got to create that list. And so, unfortunately, this doesn't, you can't fit all this in the parentheses, but we're going to write it like that. And you could effectively do this by creating a temporary variable. So, temp gets that, and we have this inner list comprehension. We're going to do a for. Yeah, this is the good way to think about it. Because, you know, it doesn't have to convert directly to a for loop. It doesn't necessarily do that. It probably executes optimized code for doing exactly this sort of thing, rather than the more generic for loop code. Anyways, that's specialized stuff. Okay, so we're going to for row in M, that's what we said, for row in M. We are going to append row element I. Oh, yep, okay, that's fine. We are going to say temp.append row element I. Because whatever appears on the left of the for gets appended here. All right, and so if you were to do this, then it's a little bit more clear this way, right? That we're going to start out with I is going to start out at 0, and that's the outer for loop. We're going to append whatever happens after executing this code. This code is the inner for loop. We're going to start out with this temporary empty array, and we're going to append row element I. Row is going to take on initially this. We're going to take on row, from the first row, we're going to take the 0th element, 1. From the second row, we're going to take the 4th element, 4. We're going to append those to our temporary variable. We get this list, and we're going to append that list to our outer list MT, and so on and so on. That's how we repeat it. So this is maybe a way of visualizing how this looks as a double for loop, at least in concept, although you kind of need to master what this means independently of how you might write it as multiple for loops, because ultimately this is, you know, while it can be visualized as double for loops, that's not exactly necessarily what's happening in code. This is what's happening, and so this is maybe conceptually the way to write it.